Hello and welcome to the unit internalization video for the Pushes and Pulls Amplify Science unit. My name is Sean Tamers of KIPP, Massachusetts. I'm going to walk you through this unit in this video. And I'd like to give a huge shout out to Jenna Bretzman of North Carolina who put together these master teacher materials. Before we begin, please make sure you've done the following. You're going to need copies of the focus tasks and editing unit assessment to complete as you work through this video. Pause now and complete these tasks if you haven't already. All right, our big unit question and anchor phenomena for this unit is, how can we create a pinball machine for our class? Since this unit is all about studying forces of movement and motion, we're going to use pinball machines as a way to learn about each of our key ideas systematically.
May the force be with you.
Ah, yes, pinball machines in all their glory. Students will see videos of complex pinball machines like this, as well as more simple homemade devices such as this. And throughout each stage in the unit, they'll make their own pinball machine, shown on the left, with increasing complexity, and we'll make a class model of a pinball machine shown on the right. Students will go through the engineering design process and learn about key concepts by making pinball machines of increasing complexity until the very end of the unit. So why does this unit matter? Well, it serves as an important foundation for students to study physics. In third grade, they're going to be introduced to the idea of gravity and balanced forces. So you're going to need to understand how forces are pushes and pulls, and the importance of direction of force. Later on in middle school, students start to add quantities to the amount of force applied to do mathematical problems related to force. Students are also going to study the concept of friction and how it can slow down objects. Finally, by understanding that all objects won't change their motion unless another force is applied to them, we're setting kids up to understand Newton's 3 laws of motion later on in middle school. Nice. And finally, we're learning about the engineering design process and how knowledge of force is important in constructing things. All right, let's get into our chapter overviews. Our first big question is, what makes objects start to move? We begin by looking at examples of objects that are moving and learn the keywords push and pull. Students look at pictures to identify what's pushed or pulled in each image in order to understand how that movement occurs. Students are going to play a game throughout the unit called rug ball, where they sit in a circle on the rug and push a foam ball in different directions to learn about different key ideas. Next, students conduct an investigation with a variety of materials shown here, where they use those materials to push or pull different objects. Then students read the book talking about forces, or they see more examples of forces and learn the key word exerted and the importance of using scientific vocabulary when discussing forces. Next, students are introduced to the engineering design process, which they'll be coming back to again and again throughout the unit as they make their pinball machine models. Their models will be cardboard boxes like this, and students are initially given a tennis ball and a rubber band and are challenged to try and move the tennis ball with the rubber band. Ultimately, students accomplish this by stringing the rubber band across the box and pulling on it and letting go. Students then diagram how they did this, and from now on they'll refer to the rubber band as a launcher. Next, the class creates a class model of the pinball machine using a pegboard in order to review key concepts of motion. At this point, students should understand progress build 1. An object starts moving when a force is exerted on it. Students demonstrate their understanding by completing the Progress Build 1 focus task, shown here. Take a few minutes to complete the task, and then check back here for an exemplar response. Go ahead and pause now. Great, go ahead and compare your response to this exemplar here. Go ahead and pause now. Note that students are going to be creating similar diagrams for each focus task, so students will start to get accustomed to drawing arrows and labeling their diagrams with each attempt. All right, on to big question number 2. What makes objects move a longer or shorter distance? We begin this section of the unit by playing rug ball once again. We introduce the terms longer and shorter as students play rug ball and discuss what would cause the ball to travel a shorter distance or a longer distance. That is, by exerting a gentle force or a strong force. Next, students read the book Forces and Ball Games, and they see lots of examples of gentle forces causing balls to move a short distance and strong forces causing balls to move a long distance. They then model strong and gentle forces by placing a paper mat mat in their pinball models and pulling the rubber bands gently to cause the ball to go a short distance and pulling it back much further with stronger force to cause their ball to go a long distance. Students then diagram how they were able to get the ball to move a long or a short distance on their models. All this leads to students understanding progress build 2. A strong force will cause the object to move a long distance, while a gentle force will cause the object to move a short distance. At this point, students complete the progress build 2 focus task to demonstrate their understanding so far this unit. Go ahead and take a few minutes to complete it now and then check back here for an exemplar response. Go ahead and pause now. Great, go ahead and compare your answer to mine. All right, on to big question number 3. What makes objects go in a certain direction? We start this part of the unit by playing rug ball once again and reviewing the key vocabulary right and left as students attempt to push the ball to the right or to the left back and forth to each other. We then read the book Building with Forces to see how exerting force to the right or the left causes objects to move to the right or left in the real world context of construction. Students then place a left/right paper mat in their pinball models and figure out how to make their ball go to the left side or the right side of their pinball machine. Once they have accomplished this, they diagram how they did it. Next, they attempt to aim the ball at specific targets. They play the game rug ball again, but this time try and push it towards a target. Once again, they discuss what caused the ball to move in a certain direction. They then place a target mat in their pinball models and attempt to move the ball towards a specific target. They'll need to pull the rubber band with a string in certain places, either on the right side or the left side of the rubber band, in order to make it go to a specific spot. Then they'll diagram how they accomplish this in their notebooks. All this leads to students understanding progress build 3. An object starts to move in the direction of the force exerted on it. Go ahead and take a few minutes to complete the Progress Build 3 focus task, and then check back here for the answers. Pause now. Great, your diagram should look like this one, and your sentences should be completed. On to big question number 4. Once they're moving, what makes objects change direction? Students begin this final part of the unit by playing rug ball once again and bouncing the foam ball off of different objects in the classroom. They then return to the reference book Forces and Ball Games and watch several videos of sports to see examples of objects changing direction, each time noting that the object has to come into contact with another object in order to change direction. They then add flippers and bumpers to their pinball models in order to get their ball to change direction, and then diagram how they did it. Ultimately, they discover that by pulling down on the flippers, they can push the ball back up towards the top of their model, and rubber bands and sticks at the top of the model will cause the ball to change direction. They also build their whole class model to include bumpers and flippers as well. By this point, they should understand Progress Build 4, moving or still object. Go ahead and take a few minutes to complete the Progress Build 4 focus task now, and then check back here. Pausing now. Great, go ahead and check your answers and compare it to mine. All right, at this point, there are several additional lessons before the end of the unit assessment, where students apply what they've learned to new situations and contexts and learn more about engineering and investigations. Students read the book Room 4 Solves a Problem to learn more about the engineering design process. They then work to improve their pinball models to do specific things, using a design goals checklist to make more fun and complex pinball models that accomplish certain things, including hitting targets. Finally, we have an optional lesson where students write a mini book to summarize the key ideas they've learned this unit. All right, on to the end of unit assessment. Each question on the assessment assesses a specific progress build level. Here's a question that assesses progress build 1. Go ahead and complete it and then check back here for answers. And here's the correct answers. And once again, this assesses Progress Build 1. Smiling and thinking are not examples of forces. All right, this question assesses Progress Build 2. Go ahead and complete it now and then check back here. And here's the answers right here. This question assesses Progress Build 3 about direction. Go ahead and complete it now. And check your answers with mine. And finally, Progress Build 4 about changing direction. Go ahead and complete this. And here's my answer. Students need to show that not only did the ball change direction, but there was a specific object or force that caused it to change direction. All right, that's it for today. Thank you so much for taking the time to be as prepared as possible to teach this unit. Some additional final steps are shown here. Go ahead and complete these in order to be fully prepared for your students. Thanks again.